Hello, it's time to talk about objects in the universe. We have planets and planetary systems. Planets not just around our sun, but also around different stars throughout the universe. We have moons orbiting planets. We have the stars arranged into mega structures like Catherine wheels called galaxies. In the spiral arm of the galaxy, we will have open clusters, a collection of between 100 and 100,000 stars, which are very new. Within the central disk of the galaxy, we have globular clusters, which are a collection of 100, possibly 100,000 to 1,000,000 stars that are much older in duration, and our star is part of a stellar cluster called Laniakea, which is about 1 million parsecs across. Of course, if we're talking about parsecs, we need to talk about what that means. We don't want to use kilometers or miles. We're measuring distances, and we're talking about space because those distances are too vast. So instead, we use a parsec. Before I tell you what that is, we need to discuss the fact that the Earth orbits the sun, right? 1 complete year, that's what a year is. The Earth orbits the sun. And even though there are minor fluctuations in the distance between the Earth and the sun, there is an average distance. You can imagine that as the radius of the Earth's circular orbit, and we can define that distance as 1, right? I can call it 1, and we call it astronomical unit. And if we looked out into the night sky onto a not too distant star, let's say we did that in January, and then we did the same thing again in June, July, 6 months later, well, the Earth has gone from one side of the sun, completed half an orbit and gone completely over to the other side, and so the star will have shifted in position relative to the backdrop of much more distant stars in the sky. One way to test this in your everyday life is to simply hold out your thumb at arm's length, close one eye, and then switch eyes, and you'll notice your thumb is moving as you switch eyes, right? This is called parallax. So if we go back to our Earth discussion, when the Earth is on the right-hand side of the sun, the star will appear in one position, and then when the when the Earth's on the other side, the star will appear in another position. We can use that to measure what is called the angle that the star makes to the Earth on the right-hand side of the sun and the Earth on the left-hand side of the sun. Normally those angles are very, very small. And in fact, we need to divide the degree, the unit of measurement of angle of 1 degree. We need to divide it by 60, and we'll call that an arc minute. So that's 1/60th of a degree. I'm going to divide that again by 60 into what is called an arc second. So now 1/60th of 1/60th of a degree. Okay, so 1/3600th of a degree. When a star makes an angle of 1/3600th, we're going to call it an arc second, with the Earth's average separation to the sun, then we say that that star is a distance of 1 parsec, okay? And so if somebody said, okay, the star is 10 parsecs away, you would know that that angle is actually 1/10 of the arc second angle we just mentioned. And so it would be 0.1 arc seconds of angle between the star and the Earth on the right-hand side of the orbit and the sun. That is the astronomical unit, the average Earth-Sun distance, the radius of the Earth's orbit, okay? Conversely, if someone said, the star is a distance of 0.1 parsecs away from the Earth, and then you would know, okay, so the angle that that star makes with the Earth's radius of orbit is 10 arc seconds, or 1/360th of a degree, okay? So next time you look up into the night sky, to be aware of all the different objects that are out there and how we can, one method at least that we described, to measure their distance. Okay, well done.